Welcome to Chem Time. Yes, welcome to the YouTube video presentation. Today's presentation is continuation on concepts required for solving material and energy balances, and today's concepts are on ideal gas laws. And this presentation is useful to chemistry, physics, chemical engineering, petroleum engineering, and pharmaceutical engineering students. Ideal gas laws include Boyle's law, Charles' law, Dalton's law, Gay-Lussac law, and Avogadro's law. The ideal gas is one where the intermolecular forces between the gas molecules become equal to zero. And this happens at very low pressure and high enough temperature. And this is the case normally at the discharge end of the turbine or at the inlet of the air compressor. And the assumption of ideal gas is normally not valid at the discharge end of air compressor or the inlet of turbine where the pressures are expected to be higher. As far as Boyle's law is concerned, it states that for a given amount of gas at constant temperature, the pressure is inversely proportional to the volume of the gas. Mathematically written, P is proportional to 1 by V, mass and temperature constant. The above equation can be written as PV is equal to constant. Charles' law. The law states that for a given amount of gas at constant pressure, the volume of the gas is directly proportional to absolute temperature. Written mathematically, V is proportional to T at constant pressure for a given mass of gas, or P by T is equal to constant. And the Charles' law can be used to determine the Kelvin scale at 0. Dalton's law. The law states that the total pressure of a gas in a mixture of gases is equal to sum of the partial pressures of each gas. For example, if there are three gases with partial pressures PA, PB, and PC, the total pressure of the gas is denoted as P, and as per Dalton's law, this is equal to P is equal to PA plus PB plus PC. And partial pressure of a gas is defined as the pressure exerted by the gas if the gas alone occupies the entire volume of gas mixture. The partial pressure of the gas is calculated as partial pressure is equal to mole fraction into total pressure. And mole fraction, as we have seen in our last presentation, is equal to moles by total moles. Next law is Gay-Lussac law. The law states that at constant volume, the pressure of the gas is directly proportional to absolute temperature. That is, P is proportional to T, or P by T is equal to constant. Avogadro's law, or it is also known as Leduc's law. As per this law, the total volume of gas mixture is equal to sum of the volumes of pure component volumes of the gas mixture. Sum of the volumes of pure component volumes of gas mixture. Standard conditions of temperature and pressure are defined with respect to 0 degrees centigrade and a pressure of 1 atmosphere. And these are useful for expressing the gas flow rate in terms of mass flow rate, and most of the industries adopt this nomenclature. NTP refer to normal conditions of temperature and pressure and refer to 15 degrees centigrade and 1 atmosphere. The significance of these conditions is 1 mole of any gas at STP occupies 22.4 liters. And this condition of 1 mole of gas occupying 22.4 liters at STP can be used for calculating the mass flow rate that we'll see as we go along our presentations. Now, I'm showing a website data on production of a company called Clean Air, where they are showing their capacity, oxygen capacity of 450 nm³ per hour. And here the flow rates are mentioned in terms of nm³ per hour. And this flow rate mentioned in nm³ per hour can be converted easily into kgs per hour. Now, ideal gas law can be written as PV is equal to nRT. The above equation R is known as universal gas constant. If you want to obtain the specific gas constant, the universal gas constant has to be divided by molar mass or molecular weight of the gas. At two different conditions of temperature, pressure and volume, the gas law can be written as P1V1 by T1 is equal to P2V2 by T2 is equal to NR. Since R is a constant, NR is a constant. That means when you're writing ideal gas law, basically you are making moles balance, and this suggests moles are conserved, and ideal gas law is one way of representation of conservation of moles when there is no chemical reaction. In the next presentation, we'll discuss about various unit operations that we need to understand for solving problems related to these concepts. With this, I conclude my presentation. I request you to like, share and subscribe my channel.